speaker for this Pioneer 1 cohort is Jessica Zurlo. And Jessica is advised by Professor Janet Van Helm. She went to Radboud University in Nijmegen. Her major is biology. In particular, she's going for the genetics and developmental biology option. And she's also a minor in psychology. And she's going to be talking to us about the effect of voice onset timing on Dutch and English monolinguals and bilinguals.
All right, thank you. As Julie said, I'm Jessica Zurlo, and I was particularly interested in how the effects of voice onset timing in Dutch and English monolinguals and bilinguals affect their perception of the languages. So to give you a little bit of background, there have been studies in the past that have shown asymmetries in the recognition of sequences other than the phonological domain, so for example of pictures. Infants have been shown to recognize a picture of a dog in a sequence of cats, but not the other way around. And then also in the phonological domain, infants have been able to recognize when the non-word ton is mispronounced as ton, but they don't recognize when ton is mispronounced as pon. Also, Antje Stoor has been here at Penn State, I think 2 years ago now, and she was researching asymmetries also in perception of voice onset timing. And she saw that voice onset times in English monolinguals there's been an asymmetry when the phoneme b as in bottle is mispronounced with p as in pottle. In ERP there's been an N400 effect, and then when pencil is mispronounced as bensel, no N400 effect has been found. And just for reference, I've highlighted all of the English phonemes with blue, and then later on, because I'm also going to be talking about Dutch phonemes, they're going to be in red. And back to the slide. The opposite asymmetry has been found with Dutch toddlers using the preferential looking paradigm. So they have found that like a word in Dutch that starts with the P phoneme is going to be recognized when it's mispronounced with the B phoneme. However, this has not been found with English or with Dutch adults because the preferential looking paradigm may just not be sensitive enough to actually be able to pick up on this asymmetry in adults. So for my study, I tried to find this asymmetry in Dutch adults, and we did this using voice onset time. And voice onset time is the time period between vocal fold vibration and when the lips open. So I have this diagram up here that you can see the differences between English and Dutch VOTs, particularly with the B and P sounds. So because of VOTs, the Dutch and English B and P phoneme sounds sound different. So what's most interesting is that the English B phoneme and then the Dutch P phoneme sound the most alike. And then the other two phonemes in English and Dutch are very different. So in my experiment, we were asking two questions. The first being, do English monolingual adults and Dutch adults without English immersion experience show the expected asymmetries in reaction times to mispronunciations? And then the second research question was, do Dutch-English bilinguals with immersion experience show the asymmetries the same as English monolingual group, the Dutch-English bilinguals without immersion experience, or both? So in my research, we had 25, well, we will have 25 English monolingual adults tested in English only. Those will be tested at Penn State. And then I went to Nijmegen at Radboud University and tested 25 Dutch-English bilinguals without immersion experience. And these were tested in Dutch only. And they are bilinguals because, as Amy said, everyone there is pretty proficient in English, so there was no English or Dutch monolingual population to test. But then I also tested 11 Dutch-English bilinguals, so 7 with immersion experience and then 4 without immersion experience in both Dutch and English. Okay. And then for the actual experiment tasks, The Dutch English or bilinguals came in and did a Lextail proficiency task. This was done in both Dutch and English for all bilinguals, and then at Penn State we're going to be also using the Lextail task to test English proficiency in English only. And then the ANT task was used to test executive function. And then because I'm looking at VOTs and how people respond to VOT changes, I also asked the participants to name some pictures so that we can measure their VOT. And this was done in the L1 for all participants, and then also in the L2 for the bilinguals that were being tested in both Dutch and English. And then the critical task consisted of the participants being shown a picture on the screen and then listening to a word being played, and then they were asked to indicate whether the picture matched the word through pronunciation, or the actual, like, did it match, in fact, the picture just based on the word itself. So there were 3 conditions for the task, and then the matching mismatch task. And then the first was, did the picture actually match the word? So they were shown a picture on the screen like this, and they heard something like this.
Boy.
So this would be correct. They would press that that was correct. The second condition was a mispronunciation of the word matching the picture. So in the English task, again, they were shown a picture of, say, a boy, and then in the English task, they would hear an English phoneme switch. So the b and boy would be switched to p, as in poi, so they would hear something like this.
Boy.
And then there was also another condition where the English phoneme was switched to the Dutch phoneme, so they would hear something like this.
Boy.
And then the Dutch phoneme, if you recall, has a slight pre-voicing, so there is a slight difference between the English and Dutch phoneme. And then, as another control, there is a complete semantic mismatch between the word and the picture. So they would hear something like this.
Mountain.
Which obviously is not correct. Our predictions for this experiment were that the English monolinguals would have faster reaction times when b is mispronounced as p during the English task, and then the Dutch English bilinguals without immersion experience would have the opposite effect. So when the p phoneme in Dutch is mispronounced with b, it would be a faster reaction time. And then we were also saying that the Dutch English bilinguals with immersion experience could perceive the mispronunciations in the same way as monolinguals for each group. So in the Dutch task, they would react quicker to the p to b change than the b to p change, and then the reverse for the English task. However, these bilinguals could also show none of these asymmetries simply because they are exposed to both English and Dutch, and they have been immersed in the English culture, so they may not be sensitive to or that discriminating between phonemes and phoneme changes within the languages. So for results so far, I've analyzed the Dutch-English bilingual groups. I have not yet tested all of the monolingual participants, so they're not going to be represented here. But going along with the theme that I've been doing, all of the variations of red are going to be the Dutch English bilinguals, and then the variation of blue is the variation of red is the Dutch English bilinguals in the Dutch tasks, and then the blue is their English task performance. So the darker colored bars are without immersion experience, and then the lighter colored bars are with immersion experience. So we can see all of the Dutch English bilinguals do react very quickly or have a high accuracy in recognizing the p to b phoneme change in Dutch, and then they don't have the b to p phoneme change accuracy in Dutch, but they do have this accuracy in English. And then the t to d and d to t conditions are also up here because they're in English similar. They're voiced to voiceless and voiceless to voiced. So they're very similar to the P to B conditions. So in conclusion, as we predicted, the Dutch English bilinguals without immersion experience tested in Dutch are more accurate at determining the p to b and t to d switches, resulting in mispronunciations. And then all Dutch-English bilinguals did categorize the mispronunciation as a mispronunciation when the VOT is switched to having a longer phoneme in Dutch. The bilinguals with immersion experience are as accurate as the bilinguals without immersion experience at recognizing the phoneme changes in Dutch tasks. So that was interesting. I didn't necessarily expect to see that because they could be sensitive and non-discriminatory. All the Dutch-English bilinguals did show asymmetries in their perception of VOT, which is also interesting because that was something that has not been able to be shown previously. And then, as I said earlier, bilinguals with and without immersion experience tested in English do pattern with English monolinguals, or what we expect English monolinguals would have. And then Store et al. Did find this in their research, so that's also very encouraging. And then finally, bilinguals with and without immersion experience tested are not accurate at detecting the voiceless to voiced switches in English tasks, which is exactly what we expected too. So it was nice to see that they were patterning with the English speakers tested in Antje's research. And then finally, I just wanted to talk about my PIA experience a little bit. This is a collection of pictures from the Netherlands, various places that we were, and some activities that we did. It was such a great experience to be able to go to the Netherlands and to be able to work with Antje again. She was basically the reason why this project took off in the first place because of her research here at Penn State. And then I'm also very thankful I got to work with Dr. James McQueen in his lab. He provided a lot of great insight, and I was also really thrilled that I could go and experience the Netherlands and be there with some amazing Penn State students as well. So again, thank you very much to everyone, especially Dr. Van Hel, Antje Store, James McQueen, and then last but not least, PIRE and the NSF for giving this grant.
I noticed that the asymmetry in both cases, everybody seems to be better at distinguishing a deviation from a VOT near zero. So I'm wondering if there's something special about zero, because the VOT boundaries that are found in human language, that there seems to be something special about zero. Even chinchillas, and if I remember correctly, chickens can detect those boundaries. Okay. So is there something special about a VOT near zero, the simultaneity of the burst and the onset of voicing?
I am not exactly entirely sure about that, but I do know in the research I mentioned previously, the Suhi et al. Paper, they did find that the T phoneme in Dutch has a higher frequency when being produced through VOT, so that's why maybe that they were it was more salient for them, so maybe that was a reason that closer to zero would have more salient. Yeah, it would be more salient.
Next time we're going to test bilingual chickens. Any other questions?
Sorry, I don't think I understood what you said about the frequency of T. Could you say again, please?
Yeah. So basically, what they had found was that here it is. So T, when produced, has like a higher frequency sound burst. Yeah, exactly. So they were thinking, and it was just speculated in this paper, that the reason why pan, when it's mispronounced as tan, is recognized is because T actually has a higher frequency, so you're adding something to the word, and so they think that because you're adding this, they don't categorize it as like missing the sound, like they think that, oh yeah, definitely something has changed, that we didn't just miss, like in the second condition when tan is mispronounced as pan, they just assumed that participants thought that they missed the beginning sound of pan.
So then what's special about zero might be that when you go from short lag to pre-voicing, you're adding pre-voicing.
Exactly.
When you go from short lag to long lag, you're adding aspiration.
Exactly.
Cool.
Any other questions? So I think we've, for 3 hours, we've seen amazing stories and amazing research by undergraduate students, and I think they all share their love for languages, but I find it fascinating. They come from so many different majors. So some students major in one of the languages, other students major in biomedical engineering or genetic biology. So I think we all inspire them with the love of language and language science research. And I'm sure they're going to do great things after they graduate from Penn State. So I would like to thank all the students for their wonderful presentations and all the work they put into it, as well as their advisors, because students are wonderful, but you know, even the most talented students, you need to mentor them in the way to become, to move beyond themselves. So please, a round of applause for the students. Broader CLS community for helping these students and mentoring their qualities. And before we all leave, I would like to invite all the students for another picture, so Jack, yours on as well. Because some students have class at the beginning of the session, so it would be nice to have pictures of all the students. So anyone who's not an undergraduate student is welcome to leave, but I would like to ask the undergraduate students to stay a little bit longer with us.